Hi everyone, my name is Martin Wendt from Potsdam University and I'm talking today about our results on the dust metallicity anisotropy of the Circum-Galactic Medium. I'm part of the MUSE gas flow and wind, or in short megaflow team, and the PI of Nicolas Boucher, and we are targeting 22 quasars with MUSE, and we're looking for absorber galaxy pairs in our data. So there's a couple of references to former papers from our project on the site, and I will now continue with these particular cases where we are looking for these absorber galaxy pairs, where we also have in addition high resolution UV data, including low ions. So these low ions we use to, in general, estimate the dust depletion of the gas in the halo. So we have, here's a simple schematic, so you have the galactic disk, and the idea is the expectation would be to have this outflow gas driven by supernovae and so on along or perpendicularly to the disk, whereas along the major axis of the disk you would expect the accretion of the less depleted lower metallicity gas, maybe even IgM coming in. So how to get an idea of the dust content of gas with background quasars? So we measure low elements like manganese or singly ionized elements like manganese, zinc, or iron. And since it is known that zinc depletes in particularly little onto dust, and for example, iron has a strong depletion onto dust, we can derive the zinc over iron ratio as a proxy for dust depletion. And in the absence of iron or zinc, we can also use other elements like manganese or chromium, because in the DeCia model 2016, based on also the idea in Jenkins 2009, you can basically attribute a sort of depletion potential to individual elements. So zinc having the lowest depletion potential, manganese somewhere in between, and so on and so forth. And so you can apply a direct fit and derive then the dust depletion from the slope. And that's what we did for all of these 13 quasar galaxy pairs. And we have in addition the information of the azimuthal angle, meaning the orientation of the galactic disk or of the galactic major axis to the background quasar that we have observed in the field of view of MUSE. And that is because we have full kinemorphological models in the 3D data of MUSE of these individual galaxies. And if you combine this information, so the measured dust content along with this azimuthal angle, meaning the orientation with respect to the major axis of the galaxy, we directly observe what you could expect for the first time. We see that we have at low azimuthal angles, meaning along the major axis, we have this low zinc over iron, meaning low dust depletion, lower dust content in this gas, whereas along the perpendicularly to the major axis, along the minor axis, we see a high zinc over iron, meaning basically a high dust depletion, a high dust content, as you could really expect here in CS. And we have additional information since we know all these orientation on the sky and distance from the galaxy to the sideline to the quasar. We also have the impact parameter. And if you combine this information, we can build up this sort of quadrant of our projected galaxy on the sky. It is degenerate for these 4 quadrants will be here for this plot we just mirrored it, and you can really see we have the galactic disk with the accretion here. Beta points out to 50 or 80 kiloparsecs, and we have the high dust content as outflows, or as interpreted as outflows perpendicularly to the galactic disk. And we can translate that also into metallicity. So if we apply or assume a correlation between zinc over iron metallicity, and there's a known correlation, rather simple correlation, even though it has a large intrinsic scatter, we can directly scale our measurements to metallicity. And here we choose a color scheme and size, so we can directly compare it, for example, to a recent publication 2020 from Peru et al. On the TNG simulations, where they really show this bimodality and metallicity that we can directly match with our information. There's also other papers like Van der Voort 2020, which also predict sort of this trend with metallicity and azimuthal angle that we are able to derive from our observations. Okay, thanks for listening. Here you can fetch our latest paper, and we're happy to discuss the results with you. Thank you very much.